let's start with VOD. And so, I mean, I mean, let's start at the beginning, right? Like, somebody has content, and and you know, like a VOD pipeline from somebody has content, they license content, they bought content, they have content, and um, yeah, let's just start there.
Okay. I mean, I don't know if you want to know anything about me or my background or why you know, why people pointed you to me.
You see how like out of it I am right now?
Yeah, yeah. I mean, I don't know how qualified I am to have a conversation here, but maybe I can tell you why, other people think I am. Um, so yeah, I've been working with Akamai for about 20 years. I worked with other CDNs before then, competitors of Akamai until we got assimilated into the Borg. Um, the so I've got about 25 years in the media space, working in the streaming technology business all that time, and seen it come from real networks and Windows Media all the way through Flash and Adobe HDS and HLS and Dash and CMAF and all that good stuff. So if you ask me if things have gotten easier, I would say they've gotten harder. It's more complex. We're trying to do more with this network that doesn't really support streaming, right? So
I mean, so if you've been with Akamai for 20 years, I mean, that's when was Akamai founded? Probably like what?
1998.
Yeah, I was just saying, not much longer before that. I mean, CDN as a concept, wasn't. I mean, I love the simplicity of the original CDN. It was like, hey, look, we're gonna have servers, and we're gonna put your servers closer to where your users are, and we're gonna make your web page go faster. And in the late 90s, that was a real big issue. AOL was trying to solve that problem with their proxies. Well, they were trying to solve two problems. One was how do they like not completely oversaturate their network, but also how to give a faster user experience. And for people that weren't on the internet in the late 90s, I mean, we're talking about the conversion of dial-up modems to digital subscriber line DSL and cable modems coming out, and it was still latency. I mean, now everybody wants to talk about latency and edge, but very different world. It was nice to have a CDN.
Yeah, yeah, and I think this ISPs like AOL, since you mentioned them, loved CDNs because they actually offloaded, the heavy lifting for their user base onto a CDN caching platform that was running inside their own local data centers, right? So it's like, great, we don't have to spit this stuff out of our data center just to go to an origin somewhere else. We can save on bandwidth both in transit, to the origin as ever, so it was actually a really good relationship when CDNs started going into ISPs and going, hey, we can help you.
Yeah, I mean, caching nodes sitting next to a DSLAM or sitting next to a head end, really efficient architecture. I mean, and like ISP and access networks evolved over time, and network capacity changes over time. But I think to your earlier point, right? Like it's not simpler. It's just we have more going for it.
Yeah, let's not just do caching of objects. Let's do pages that are unique to every end user, and it has to be, go through a network that goes to a server that says, "Oh, because you're you, I need to serve this version of this page, not another version." So yeah, it's caching is hybrid now, right?
Well, I think the other part of this that became when we talk about CDNs, and I look at CDNs, it became what are you using and how do you actually determine what edge node to get to. And this is also, I guess, foundational to this conversation, which is, are you using a BGP and ECAST, good and bad? Are you doing DNS, good and bad? A lot of people in market right now trying to do peer to peer, good and bad. Like it's and I guess I've been in tech long enough that when people ask me questions, there's like my brain immediately goes to, well, it depends.
Yeah, and nobody likes that answer.
Oh no, it's I try to simplify it. I've also learned over the years that like sometimes people are just looking for the simple answer, but the it depends really drives a lot of the conversation, right? I mean, you were talking about codecs, right? And these conversions between real media and Dash and HLS and all these other things that are out there, and that is a big it depends as well in terms of what you think about with your content, how you deliver it. And um, there were CDNs that launched that really tried to split. And this was an architecture and efficiency, right? Like small object versus large object, and how do they actually optimize for that? And then everything just kind of became, everything was small and everything was large, so there was really no difference between one and the other on these things.
Yeah, and I think all CDNs play that game a little differently, right? So, do you do byte range requests or do you not, right? For large objects, and do you cache those byte ranges and without going back to the origin or partially or something? So there's a lot of differences that I think when you talk to companies that do multi CDN, they realize that there are so many differences in how different CDNs work and operate.
Let's dig into multi CDN for a moment. And I feel like multi CDN was a precursor to what a lot of people talk about in terms of multi-cloud now. And there's a big push for it. Not necessarily. I feel like the biggest push always comes from a resiliency or redundancy or like these sorts of things, as opposed to a feature set. So when I hear people talking about multi-cloud strategy, they're usually saying, "Oh, we should put some stuff here and some stuff there as well, just in case this thing goes down, and then we can go over here." And I hear that same conversation related to CDNs, like, "Oh, you should have multi-C." Now, um, with the exception of geopolitical influences in specific regions and capacity limitations, right? Like multi CDN from a like, oh, we should have redundancy always is like, it feels like the wrong conversation to be in, because you can get redundancy out of it. But at the same time, like, it's not, you have to optimize for your CDNs differently. Like CDNs do different things.
True. So there are definitely pieces of the workflow that are going to be impacted like that. For example, token authentication. I don't know how deep you want to go into that, but every CDN has done token authentication. If you don't know what that is a either a query string or a header or something in the URL itself that makes the URL unique to that user, right? So it's a token that you get applied when you log in for streaming, for example. If you log into a streaming workflow through a paywall, you're going to get a token that CDN knows how to interpret and see what the secret and the salt are and identify whether or not you should be able to view that stream. It's different across all CDNs until recently. Now we've got this thing called Common Access Token, which I know that Will Law, if anybody's ever seen him speak, he's an Akamai person, but he's also just a generalist in the streaming world. But Common Access Token is a thing, and we as a CDN embrace it because we hate the fact that we have to, comply with or build something special that goes with this CDN or that CDN. So when you say multi CDN, there are certain components of the technology that you have to normalize. You have to limit, kind of the least common denominator, if you will, right? So it does rule out some advanced features that some CDNs might want to offer you if you're across multi CDNs. So yeah, you have to be careful of that.
Well, it also introduces another thing as well, which is you have to decide which seating to send traffic to, and then what's the mechanism. Now, if you're doing video and you have a player, you can put a lot of that logic into the player. If you're talking about delivering a web page, you don't have access to the player to drive that logic. If it's a mobile app, you can put logic there, but then you get into some other logic engine that you have to route traffic through, and this is from like the network engineering days, right? You're like, you try to like, you're always trying to quash that like failure point, and all you end up doing is introducing 37 more. So like, did it solve the problem, or did you introduce a new one?
Well, and with VOD, I mean, I know you wanted to start with VOD for streaming. Multi CDN is less of a concern from an availability perspective. It's more of a contractual, obligation, retire whatever your contract commitment is. And we find that customers will bounce traffic back and forth for those reasons, but also from different geographies. We all have servers in different ISPs that might perform better than others for certain end users. So People will shape their traffic based on performance for that reason. But from an availability perspective, from a VOD perspective, availability doesn't really come into play because you can cache the content everywhere, right? It's, popular content. The rare use cases that VOD acts like live are like when you release, the final season of Game of Thrones or something like that, right? That it becomes a live scenario where your cache is trying to fill up as fast as you can. You can game that, you can deploy it, you can, pre-populate the cache. There are certainly ways to do that. But that's the VOD world. It's more of a load balance because I want I want to save money here or there, or I want to bounce things around the world differently.
I was having this conversation really and recently, and it's funny to me because you start as a computer and network engineer, and you kind of work your way up. And right now, people ask me, and I would still say I'm an engineer, but most of what I'm engineering is financials. And you're like, oh, what's our and here's an example, right? CDN, like, what's our rate over here? What's our rate over here? How do we maximize our cost based on this? Oh, we have a commitment tier over here that we have to fill to, otherwise we're and like and then you get into like and then you get into the other fun stuff where it's this provider has a deal with this ISP and has capacity and this one doesn't, and this other thing is happening, and you I mean, it's just so funny to me always, of like, gone are the days of like trying to get our queues working on an ISA card, because it just wasn't flowing right. And now it's like, oh, we're trying to serve traffic into this and also, right, big difference between content that's going into uh, you know uh, tier one cities in the United States versus foreign markets, and then how do you deliver and how do you deal with that as well. So like where your content's actually going makes a big difference.
Yeah, and as you know, sometimes the best technical solution doesn't win because of financial reasons, right? So that
Almost every time.
yeah, so we can lay out the best technical bulletproof solution there is for any live event or live VOD scenario, and then somebody will go, yeah, but that's too expensive. So we're going to go over here and do this. And you just have to accept that and say, okay, well, if you're going to do that, these are the things you should have in place just in case something goes wrong, right?
So what are the challenges with VOD that people? I mean, because VOD from a high level architecture is really close to, as you said, it's close to any sort of traditional CDN delivery. You have an object. In this case, your object is video. But then I guess we get into, you start adding complexity to it, right? So you have authentication, you have encoding, you have variable bit rates, you have bit rate selection. Then you have like add insertions. You've all these other things that start to pile into that pretty quickly. And how much of that? Well, I mean, Mark, I mean, talk me through it. Like, what within that? How much of that is offloaded onto an Akamai at this point, and how much of that is maintained and managed by the player, and um, how much? I don't want to use this phrasing to it, but is the intelligence happening at the player and at the client side or the customer side, or are you guys driving the intelligence through the CDN, and how much of that lift can you take off of people that want to get into the VOD business?
Yeah, are we still talking about multi CDN and
No, no, no. No, I mean, the great thing about today's world is I was 20 years ago, right? 20 years ago, when you started Akamai, 20 years ago, average cost per megabit in a data center was like $8. So we were doing a lot of bandwidth manipulation to try to and it was meaningful because if you could figure out how to shunt something that was off of an $8 per meg line down to a $6 per meg line, I mean, that made a big difference. Bandwidth rates are a little different now. I mean, it's the good news is this usually isn't as big of a problem for people anymore.
yeah, but mostly the way I see people traffic shape is either through automated performance tools like Conviva. They'll have some agent in there that says, well, we're going to shape this traffic because it's not that performant in this location, and we're going to route these users to this location. But 9 times out of 10, we see DNS being the main way to do it. So they have a video.company.com domain that they will either send to one CDN or the other. to meet their traffic commitment, or they'll have a Akamai specific domain and a um, somebody else specific domain, and they'll just shape it in their CMS, their content management system, and they'll say, okay, we're going to send traffic over here for these users, and we're going to send traffic over there. Very few of our customers do it by um, different format. It used to be bigger when we had Flash servers and things like that. You would serve for that format over a certain CDN because that CDN performed better than others. But now that we're all HTTP based, it's more geography based, I would say, and commitment based, right? So in the US, we're going to satisfy this commitment that we have with this CDN or whatever. Akamai doesn't really play the geography price points. We have a single price point in all geographies for the most part for almost every customer. In the rare cases, we might negotiate some things, but I don't know of any. So those types of traffic shaping, it's mostly DNS or CMS based, from what I've seen.
And the problem with DNS based traffic shaping, well, I mean, again, I'm going to date myself. When we had the recursive DNS platforms launch, like the Open DNS was probably the first big one that got really huge. And now they're relatively everywhere, right? But I mean, I was in Los Angeles and Open DNS was in San Francisco, and so all of a sudden, anybody that was using DNS to do traffic, just hey, I'm in San Francisco and I'm sitting in my office in One Wilshire, and all my traffic is flowing up to the bay, and you're like, I actually know that your infrastructure is right next to me on the next floor. And that wasn't a great user experience. I mean, it's not as bad now, but that's still a thing.
You talk about dating yourself.
Oh man, I'm gonna date myself a lot, I'm sure.
So the AOL issue, right? Everybody looked like they were from Loudon, Virginia, right? So everybody that had an AOL login or user base, everybody was getting traffic from that location. It was ridiculous for a little while until that was solved. But yeah, there's definitely ways to do it. So when you're talking about streaming, you have various places to check where the user is, right? So you have the player, you have the landing page, you have the stream itself, you have all these things that should talk together to say, all right, based on this landing page or even this user's login, based on where they usually are. There's a whole bunch of ways to do it. But DNS does seem to be the ubiquitous, easy way to do it. That's where a lot of people do it.
Yeah, well, I mean, it is probably the easiest. I mean, it's a blunt tool. I mean, you're taking and using a 5-pound sledgehammer to try to like do finish nailing, right? It's you're going to get the rough gist of it, but not there's if you have enough traffic, it kind of smooths itself out after time, but it's not really super granular. Are people? I feel like with most of these, and with companies that are getting into streaming, right? You start talking about like, what do you build and what do you buy? I mean, this is constant with everything in tech. What do you build? What do you buy? Do you buy? Okay, you own the content. Are you buying your own encoding platforms? Are you going to use somebody else to do the encoding? Are you chunking it yourself? Do you use somebody else to do that? Are you what DRM wrapper are you using? Do you go out and buy that? Do you use somebody else's? The CMS platform, right? Like, do you go buy it? Do you just go chunk it together, right? And again, in the VOD world, a little bit easier because you actually have the content. You upload these files to your storage system, which feels like 99 out of 100 times is on S3, which causes other problems. But I won't get into let's not get into that hole just yet. But even within that, I mean, has this market at this point? I hate using like the commoditized term, but I mean, is it just have we finally reached the point where people just go out and, hey, like, I've just got this player because this player is great. I'm just going to use this player that's a known thing, and like we're off to the races.
I would say as soon as we get settled into a norm, something changes. So,
I'm going to use that quote because it's so true.
so you mentioned S3, and I'll bring up the elephant in the room. So S3 with their egress costs, I mean, it's like, okay, you put all your content on S3, then you're paying out the what if you're not caching efficiently. So there's companies that have built complete solutions around that. And Akamai has one of them. It's called Cloud Wrapper. We before we had our own cloud, we had a solution where you would only pull from the origin once, and we would cache it, and you would pay for that layer of cache, but it was a lot lower than the egress cost, right? So
Egress, S3 egress is the real mode of AWS, and people that don't understand that just haven't dealt with it yet.
right, right. Yeah. So, and this isn't an Akamai commercial, so I won't go into other things, but we have solutions around that as well. So,
No, no, no. This absolutely we should talk about this because this is, I mean, it's all relevant, right? Like there's um the origin selection and origin cost and then origin implication of that cost is a big factor here, right? And um if you've got hundreds of terabytes or petabytes worth of origin content that's sitting on S3, the cost of dealing with that, and well, this actually, I think it backs up a little bit. You start talking about what's your encoding and ingest and DRM like pipeline, and what is that feeding into, and then where is that actually going after it's run through its pipeline, and then are you making a decision to shove it onto S3, or you know take your pick of other alternative, I hate the hyperscale name, but the public cloud providers, or let's call it like media centric or CDN friendly, storage platforms that have cheap to zero cost egress, right?
yeah. Yeah. And I will bring it up. Akamai bought a cloud called the Node. So, the egress cost out of there is where we're actually seeing a lot of business being taken away from other cloud providers. But the encoding workflows, what I've found is that it is very customer specific. When you get into the large players, like the Disneys of the world, they don't want anybody else touching their secret sauce on their performance and their codec or their encoders. Sorry, they have a specific quality measurement because all of the Disney movies and everything, they fade to black. They do a lot of things that make encoding software a little bit challenging if you try and fit it into a one size fits all profile. Doesn't work.
You mean Disney's not just going out and taking FFmpeg and running like,
Yeah, no, they're not. They've built their own. So, but that's one example of one customer, and then other customers will outsource to, well, say, you know, um, if you want to use small to medium customers, we use Brightcove, the Zencoder solution. Bitmoven's out there. A lot of companies will use Elemental, of course. But when companies start using the cloud infrastructure, it's expensive, but it sucks you in and you're locked in. So it's that whole vendor lock in that, with Akamai, my being an Akamai veteran for 20 years, I've seen us get into the workflow space and then get out of it. And as a media specialist, that's painful. So I'm like, hey, what do you want to talk about today? All I got is delivery. But we're really good at that. So and we have been for a long time. So we were performance based.
I mean, that's a really good point because there's a lot of other companies that were big logo, big brand, big names in the CDN space that have evaporated in recent years. And you talk about media as well, where they had encoding and workflow pipelines, and then they got rid of those because they didn't want to invest in them anymore. And you can almost count that day as like 0 day, and then just work forward to when they were gone. Because if you've looked at or you used an elemental pipeline, and you start looking at the actual cost of these things, like it's very easy to be like, we gotta like that piece over there, that X, that block on that diagram, we got to get rid of that thing.
Yeah, we see a lot of people using open source as well. FFmpeg isn't unheard of to go out and use. I mean, it's the baseline of all encoding platforms anyway. It's just someone has built a workflow around it. So, we've got companies that have built entire VOD and live encoding workflows on Kubernetes on the Linode platform. So we see that taking off, whereas you can actually grow the scale. If you have a very large volume of content that needs to be encoded or re-encoded for the next format of choice that comes out in the next couple of years, you're stuck with this thing that you have to do something with. Now, if you can spin up, 1,500 servers and, over a course of a couple months and do a couple of petabytes, you're done. That, and then it collapses and goes away. That's one workflow that I think is definitely going to evolve and keep on happening, right? It just does. And then the packaging for DRM workflows, right? So you've got to package into different formats and different DRM schemas for, to support different DRM architecture, so, and technology. So Easy DRM is a perfect example that runs their licensing servers on the Akamai platform today. They're very happy with it because it's zero to hardly any egress costs. But it's also just license requests, right? It's not that much egress anyway, but it's just, very highly performant and moving into the most far reaches of the world a little further than the hyperscalers are today. So we've kind of taken the CDN approach that we've done where we put it, our CDN edge servers closest to the edge users. They're doing the same thing with cloud. We're trying to get into, South America and, in Brazil and Argentina and things like that, where you don't really see the other guys.
How much has Apple and Google? I mean, so Apple with Safari and of course the iPhone and mobile devices, and then Google with Chrome. I mean, now you've got relative, much smaller browser market. I mean, effectively, right? Like all the browser share is tied up with those two, and um, I'm thinking back to like when HLS and Dash, these things started launching. I mean, how much has this changed the game for people and trying to figure this stuff out?
Yeah. So Apple and iOS, they're always the ones that kind of puts everybody kind of like, oh, great, I got to support that one format because iOS doesn't support it. So, we've got people that are doing LLHLS. They can't move to complete Dash platforms. They would love to for Dash CTE. We're talking about latency earlier, but LLHLS is required for iOS. So there are still some workflows that require certain um, codecs for devices, for those specific devices, if you want to reach every device. Now, very few companies that I know will alienate an entire iOS platform of devices, right? So they will always support whatever iOS does, right? Now, when you talk about iOS making very interesting moves, the AV1 chip that's built into the iOS 15 and above, that's pretty impressive. I think it was 15, maybe 13, I can't remember. But that having that the ability to do hardware based decoding on the actual phone does help battery life, and it helps bandwidth, everything. So it's a big component of what you have to think about when you're thinking about which devices you want to support and what players and that kind of thing. Then you have the Rokus of the world and the set top boxes and the devices or the TVs, the smart TVs. There's so many different devices out there that you really still have to play the game.
I mean, so how many different formats are people encoding to at this point?
Well, we were hoping that CMAF would be the end all be all, but there's still some holdouts out there that want to have smooth streaming, for example, for some of the gaming consoles. So there's HLS dash and very little smooth these days. Now, a new one that's actually taking off is HESP, the high efficiency streaming protocol. That's actually been in NAB demos for the last couple years. It hasn't taken off a whole lot. And then for the very low latency type workflows, you've got WebRTC, right? So, you have people that really want to have two-way communication conversations. That's WebRTC, but you can't really scale that from a streaming perspective. So you're not going to see the next Olympics streamed over WebRTC ever. So that's kind of interesting. So you got those three types of workflows that we have to deal with at Akamai that people are like, I need lowest latency possible. Well, do you really? I mean, let's talk about that for a second.
Well, my version of that is every page has to be dynamic. And it's like, really? Does it? Every page? You can't cache anything.
Yeah, and the latency story is people usually want it just because they've heard about it. They're like, they have no idea what the implication of going down to 1 or 2 seconds latency from glass to glass is from an encoding workflow for live.
Well, I mean, if you're doing live events, then maybe it matters. Like if you're streaming the World Cup.
Only if you're also broadcasting it over some other means, right? If not, who's going to know but the people that are in the stadium that you're 5, 6, maybe even 15 seconds behind? Nobody's going to know.
Yeah, and in most cases, they want to delay anyways in the signal because there's other reasons for that, right?
I mean, Janet Jackson, right? The wardrobe malfunction.
Yeah, no, good, really relevant example, right? I, it's I mean the person to person live streaming, the game streaming is an interesting example of that, right? Because now I mean, I mean, to your point, you have to merge a couple of things that are not very easy to merge, and then but I mean, how much of that? I mean, you've got like person to person streaming and then you've got chat, but like you don't have a lot of people doing audio video that's more than like maybe 1 to 1, like, I mean, that's still pretty small. Otherwise, they're taking and using it as a source and then rebroadcasting it as a stream, right? Like it changed that technique changes a little bit.
Yeah. So for the, you might be talking about game streaming, but I was going to take you in a different direction, like the Twitch direction, right? So if somebody's, wanting to stream their, event going on, so gaming event, um, then I was even talking to a customer just last week saying, we need 2 seconds latency. I said, why do you need 2 seconds latency? And they said, well, we want people to be able to respond to the chat feed that's going on. I'm like, people are playing games though, right? They're playing a game and you think they have 2 seconds of latency of them in their brain to go over and look at a chat and then answer that person and go, oh, so and so is asking about da da da. It 2 seconds is not that important. It really isn't.
Well, I mean, when we started dealing with voice over IP on a global scale, there was an experiment we ran where we had and pinned a call from Los Angeles to Frankfurt and back. So it was the craziest on network thing that we could do to actually simulate network latency and start injecting things like packet loss and jitter and all these things into the call. And at that point, I think the round trip time was like 270 milliseconds, if I remember correctly. I mean, it was big, and it was fine. I mean, you couldn't tell that there was that much delay on the line. You read all these things, you're like, oh, you can't have a phone call at that kind of latency because the delay, and you're like, no, you can have a phone call just fine. It works okay.
Just watch the news, and watch one correspondent talking to another correspondent somewhere, even in the US, like east coast to coast. They're like, hey, what do you think about this? Yeah, I think it's noticeable. I mean but that's the satellite. That's not even internet. So, we're all trying to remove that latency, that two-person, two-way communication talking. And there's ways to do it, but
So that, I mean, that creates some interesting things. Like, so acquiring Linode and bringing a compute platform and a storage platform and an alternative into the Akamai umbrella, right? So now you have a commercial pressure to bring pipeline and workflow back over to you, right? Because it's, can you, I mean, is, Elemental running on Linode yet? Like, what are the big dominoes here that change that equation?
yeah, so, we're still going through a little bit of a maturity and um, credibility phase, right? We bought this company 2 years ago. It wasn't enterprise ready when we bought it. We're building it out. We started this program called the Qualified Compute Program, or Partners Program, where media specialists like myself and others in the company reached out to all these encoding partners and said, look, we got out of the encoding space 5 years ago. We're back in it. We want you to come over and build your platform on us. So, Atem, MediaXcel, Capella, Bitmovin, Harmonic, there's 5 big names that companies out there that are actually using those either on-prem, or if they're not using them on-prem, they're using them in a cloud. Um, to go to those companies and say, "Hey, we want you to run that on Akamai now," we haven't earned that credibility yet. So we're getting there. So that conversation is a slow conversation where we say, "Hey, we want you to try this with one of your streams. Give us one of your 300 streams, and move this over." And it's working. We've got I would say a dozen or so companies that have started actually working with us on that. Two or three of them have really made the commitment to say, "This is really great. This works perfect. So we're going to move everything over." And it's they have to wait till their commitment on their other cloud is expired. So
The cost differential on that has got to be just absolutely bonkers.
yeah, I mean we can well, I can't share any customer names, but I can tell you that we've seen at like 40% difference for some TCO calculators that we built. Sorry, total cost of ownership calculators.
The cloud cost, I hate another term I hate. We should actually call this out here. Repatriation from cloud. Like who comes up with this nonsense? Like why did we all of a sudden decide that it had to be called a hyperscaler? It's not a hyperscaler, it's a public cloud. Like, okay, and then you repatriation. Like this is just it's crazy, it makes me nuts. Anyways, um industry wide, people will say and use numbers, and it's like, oh, it's like 30 to 40% cheaper. Okay, like we literally just went through a project. This is a 7-figure a month spend. It's 72% cheaper for them to move on to bare metal.
Well, yeah. So yeah.
Like it's just you can't rationalize that number when you say you're gonna cut 700 I mean $1 million a month. You would cut $720,000 a month.
But the argument on that, so having sold and had many conversations about cloud with companies now, the argument on that is you are paying for that bare metal, and if you think that you have to scale for lots of
Can I roll my eyes?
yeah, so when you start to scale that and you scale it for an event or a couple of events, and then all of a sudden you don't need that infrastructure that you've just built out on prem for all that time, you know, then what?
Can I give you 2 secrets that you probably already know? The first one is elasticity is a lie for the majority of companies, right? Because as soon as you start going through any sort of cost optimization structure, you're buying reserved instances, savings plans, you're signing an EDP, you're doing something that's committing you to a spend. And it's also usually committing you to a spend increase on an annual basis. So this idea of like, oh, we're going to turn stuff off. No, you're going to share shift. You're going to spend shift, right? Because you've committed to a $20 million spend this year on this platform. Like you can go turn stuff off, but you better go spend it somewhere else because guess what? You're still writing that check, right? So that whole idea of ephemerality for reduction of cost in the real world, it doesn't happen. It actually causes a lot of pain for companies because then they realize, hey, we re-architected something, we saved a ton of money, and now we have this $500,000 shortfall that we have to plug. What can we shove into the marketplace to make up this shortfall? And that's where I see a multi-cloud disintegrate really quickly, because usually that second cloud platform, the test cloud, doesn't have the same contractual requirements, and as soon as they hit whatever point, it's like boom, that workflow gets yanked right back because there's a spend threshold. The other secret here, and this is I will get off my soapbox, I promise, but the other secret is just because you have some percentage of infrastructure on bare metal doesn't mean you can't still scale onto the cloud, right? And every single one of these that we build and deploy, we pick a steady state, we put it onto bare metal, and then you scale your whatever you need onto the public cloud, and it's really not hard. Like pick your cloud provider of choice, and the bare metal providers are getting better and better at being able to provide on demand capacity. So like that's still an option. Like there's
Well, yeah, you bring up a great point because I was talking to a broadcaster, a shopping network broadcaster. I won't mention the name. They have on-prem as well, and we're like, hey, why don't you augment that with some cloud infrastructure? They're actually using one of our QCPs, and the QCP has an orchestration layer that manages an on-prem and cloud at the same time. So it's like you won't even know the difference of where these servers are. So, you could build out more channels, build out more, whatever it is you want to do. And they were in the process of migrating their on-prem infrastructure from one location to another. And they said, yeah, we're going to be we got to do this thing where we bring these up and then we migrate things over slowly. And I was like, well, if you're in the cloud, you could just boop, then ship your stuff and then boop.
Yeah, well, that's a good example of it, right? I mean, there is, um, I mean, look, there's so many, and again, it all comes back to politics. Usually, there's so many changes that a cloud platform does for a company that's usually alleviating internal politics and you know cost-based budgeting and departmental buildbacks and like all these other things that have to happen that you go, oh, like we don't have to deal with any of that anymore. And I totally get it and I understand it. Just don't tell me, like, for the people that come at me with like, oh, the cloud's cheaper. No, it's not. That's not the problem you're solving. like like you know like you could tell me you're solving some other problem, and 100% I'm with you because I've dealt with those and I get it. I 100% get it, but like you're not saving money. So like let's just anyways, soapbox. I'll climb down. The it's I mean it's I mean because the other thing with streaming that you get into, when I say streaming, I'll use it like VOD streaming, you get into, it's like long tail content, and like how do you deal with, I mean, that's actually a unique problem to VOD versus live, right? Because long tail is an animal that it's not like people are deleting their content library randomly. How do you manage long tail effectively?
So you mentioned earlier that there's different platforms or networks or workflows for large content and small content, small pieces of content. It's the same thing for long tail and non-long tail, if you will. We architect some of the caches a little bit different to hold the cache and not age things out as often as they would normally.
You should actually, let's pause. Let's talk about that for a second. So, like foundational architecture for CDN, right? We've got content somewhere on a hard drive. So it's on the cloud, it's on S3, it's somewhere, it's on a hard drive. And the CDN, so a request comes from a browser, it has a URL. That URL is the CDN. The CDN at that point, we're talking about like the CDN edge, right? Like walk me through, yeah. So walk me through that architecture of the CDN, front to back, just for people that are watching or listening to this.
Sure. Yeah. So like you said, the content is at an origin, and the end user might request the content and go to an edge. The edge is closest to that user for performance reasons, right? Because when you cache content at the edge, you want them to have to not go through the entire workflow back to the origin if it's a long ways away. What Akamai does for streaming content, and many of other CDNs do, is there's an inner edge, if you will, called a parent tier. So the edge servers will satisfy a lot of end users that are in that same geography, right? So a single server in this, it's never one single server, but for this example, we'll call it one server, will handle many requests. So that's why you get cache efficiency. Then that parent server will handle requests from many edge servers. So you multiply the offload capability from a parent server because it's getting requests more often than the edge server. And the edge server may age things out because of other requests that are coming in for other things. There's only so much memory and storage that is allocated for that caching appliance. But this middle tier, because it's serving many edge servers, will have more requests in a given month and keep content in that location. And then your origin hopefully will receive fewer requests, many fewer requests. Now, for your long tail, there are architectures that you could build where you have committed parent tiers that have larger storage allocation as well as longer cache life, if you will. So won't age things out as often. So we do that for a lot of the broadcasters that we have.
Is origin shielding still a big thing too as well?
So the Origin Shield has a couple of different use cases and names, right? Origin Shield can be an ACL that protects the origin from only requests from certain IPs. An Origin Shield could be that parent tier that I'm talking about. In our case, that's called Cloud Wrapper. It's the same thing. Fastly calls it Origin Shield, and we call it Cloud Wrapper. That's the middle tier that has that larger, uh, I guess, cache efficiency, if you will. We built that solution for Facebook, for social networks, right? So, how many people are going to see the videos that I upload of my cat? Well, not that many people, right? But I don't want to have to go back to the origin every single. I hate cats. I'm not a cat person.
It could be a popular cat. I've seen some of those.
Yeah, I'm a flying guy. I do flying things. So, but the that concept is offload that content from the customer's origin as much as possible so that the last mile issue is our problem, not yours. We don't charge for storage on the for the most for most cases, but for that use case where you definitely want to offload from the origin, and in this case, it might be S3 where you're trying to prevent from a lot of egress cost, then that middle tier is, you kind of, it's a shell game a little bit. You're moving the cost to someone else. But the play is it works when the egress cost outweighs the actual cost that you're paying for that tier.
There was a chart that was made years ago and circulated, and it was talking about access times for CPU to like do work, and where you sit in the cache. And I think about that a lot in this example too, right? Because your edge cache is not a lot of storage, but very expensive, very fast. You're using RAM, NVMe. It's like, what's the fastest mechanism that can sit on that origin, sorry, on that edge? And then as you move farther and farther towards the origin, the storage becomes cheaper and slower, right? So like the parent cache is probably not, I mean, a mix of NVMe and SSD, right? And then you go from that, and then you get to the next tier where it's like, okay, you've gone from SSD to SATA, right? And you kind of keep working down. I mean, Facebook's storing on tape drives. Like, you want to talk about like crazy stuff, like, I mean, they've got data centers of tape, and that's not fast retrieval, but it's really cheap.
Yeah, no, everything on the Akamai platform has been replaced with SSD by now. We got like, I don't know what the number is, 300,000 servers around the world, or maybe 400,000. I don't pay attention to the marketing anymore. But the number of servers that we have is constantly, we're swapping them out for more efficient servers. That's why it's not constantly growing. We can't just throw hardware at every problem. We have to get more efficient. So, but the architecture that I just described is the architecture that is good for long tail, something for very high request rate, like APIs, things like that. Very small requests has a whole different architecture, right? So there are different networks within the CDN that you get mapped to depending on the product that you are purchasing. So yes, we have 400,000 servers, but in this particular product, we have like 150,000 servers, or this, or and some of them do multi-duty as well. So,
well, API is also different, right? You get into API, or I mean, traditional REST API or GraphQL, or at least different things, right? And part of it is caching, part of it's authentication, part of it's like being able to apply like a WAF on top of it and protect your API, from the internet, and or it's like bot, right? You're dealing with bot, and how do you, I mean, whole other can of worms, right? Like, there's all these other things with it.
yeah. Well, so what's interesting about what we've done with the cloud workflow, that we bought this cloud, all of a sudden we got all these new toys to play with. It's like, whoa, we're not committed to just the products that we build and we go through our process of productizing. It takes, Akamai, 18 months is generous when I say from idea to finish. It's probably longer than that. In order to have some bundled solution that we can resell to many customers, right? Now that we have the cloud, we've got partners like HarperDB, for example, is a distributed database. You're familiar with them? I mean, we're talking like milliseconds of time to replicate a database that we're using for, I mentioned token authentication earlier. We're doing common access token authentication with token banning through HarperDB, through for some of our larger broadcasters. It's pretty cool. And it's like it's not like sample sets. Like I'm not taking some of the requests. I'm taking every request for a TS segment and looking at a token and looking for abuse. And if I see the abuse, I can ban it or I can allow it. I mean, that's pretty cool.
I mean, it's just the cat and mouse game with this stuff is just so wild. Um, so okay, right, and then the line gets blurry because then you go into live, right, and there's like live, which is acquisition, and then there's like live in the sense of like we're gonna broadcast something, but we're gonna record it at the same time and then put it into our VOD catalog and then deliver it, right? Like so, like these lines are always kind of like as I whack my microphone here. Lines like it's like everything kind of always like lines up and gets blurry, right?
Yeah, so to me, live and simulated live are almost the same, but have different problems. The simulated live has more problems on the edge and in the network, the middle layer, because it,
What do you mean by simulated live?
like what you just said, it's pre-recorded, but it's also playing out as if it were live. So, uh, uh, I don't know why I can't. Tom Brady's roast, for example, right? So that was pre-recorded, but it was
But it has an airtime that content goes active at whatever time. Yes.
yeah. So that is what I call simulated live, right? So it's actually being kind of distributed as if it were live. It's probably VOD content might have even been going through encoders. I don't know if it was. I don't think it was, but it was probably distributed and then played back, right? So that's
So traditionally, in a broadcast situation, in the simulated live, right? What you're talking about is, um, they have the content and they've gone to a broadcast location. Usually, like these are these boxes with lots of satellite dishes on the roof, right? And they put the tape in the drive and they a lot of time they press the play button. I mean basically, right? They press the play button and it just goes out to the satellites and goes up and comes back down. Then everybody takes that signal and shoves it onto whatever mechanism that they're doing to distribute it to the eyeballs.
so you're right. So I kind of blurred the lines there a little bit. So a true simulated live is still a live workflow where you're doing encoding. It's just coming from instead of a camera pointing to a person talking, they've actually pre-recorded and probably edited it and all that stuff, and then they're saying it through live. What I'm talking about in this scenario, and simulated live was probably the wrong word for it, but it's a VOD event that acts like a live event. So it's a flash crowd event. Does that make sense? Okay. So, I mentioned earlier the release of, last season of Game of Thrones or House of the Dragons or whatever. Um, at that time, you have what any CDN might look at as a DDoS attack, but it's not. So it's like, well, what's going on? So you mentioned WAF. We have to be very careful, right? So we can't actually deny requests because it looks like a DDoS attack because it might actually be a flash crowd, right?
Now, I mean, you as a customer, right? When we were deploying infrastructure and then refreshing cache, we would go through and we would effectively spider our sites to like, you know, and we would try to do that for multiple geographies and then get, you kind of figure out like what you need to do in order to get your eyeballs the best experience. And there were different mechanisms doing this, but I mean, a lot of that's also exposed via API. CDN, you can invalidate objects with the API. Are people not like issuing like, hey, this is, by the way, you should cache this content now, and get ready.
Meaning for the simulated live workflow. Yeah. So there are sophisticated customers and there are unsophisticated customers. That's the best way I can say that. There are people that think through that and know. Um, and that not to change to live, but for live, there are a whole bunch of things that we used to do back in the day where yes, you can put a live stream on your homepage and have it autoplay, but that's probably the worst thing you can do. That means anybody that goes to your homepage is going to automatically consume streaming resources that they may not otherwise have done, right? So make them do a call to action, make them click on it. Little things like that you know that are probably natural for you and I, but not so natural for someone that's hasn't been in the live streaming game as long, right?
And for the record, I hate auto playing video on websites.
Yeah, and especially when their audio isn't muted, right? That should be a crime. Yeah. So, but so going back to the true simulated live, right? So when you have a pre-recorded thing and you're going through live, yes, there is an encoder. That encoder is sending the stream to a CDN. In most cases, it's being pulled. Uh, so
I mean, from a simulated live from a simulated live and a live, it's just what's the source? Is the source a tape deck or is the source a broadcast trailer with a mixer, right?
yeah, but there's also things that you can do ahead of time, like condition it for ad insertion, for example, right? You can have, if you do a simulated live where you've recorded it, you can have breaks that make sense that are like, oh, we're fading to black, we're doing this, we're going to go to the ads, right? So you can do that. And live football, whatever, you do the TV timeouts and the flags and you kind of have to have all those ad insertion mechanisms in there. Server side ad insertions are definitely the popular way to do it now. So, those types of things. Remember when I said it hasn't gotten easier, it's gotten more complicated? Like how do you monetize the content? How many ads do you play? Do you only play a bumper ad? Do you play mid-roll ads? I mean, there's all kinds of.
Are you playing ads based on the market that the person's actually watching in? Do you have a content distribution requirement that's some contractual deal with somebody where they control the ads and you're just giving them the source? Do you give? I mean, yeah. I mean, again, what are we actually engineering here? Video delivery or contracts?
Right. And then you've most of the people that come to me for live event scale type consulting, they'll be like, "Hey, we're worried about this stream being scalable." I'm like, "Okay, well, let's talk about the stream. That is important, but what about everything else around it?" Right? Where's your player? Where's your landing page? How are people getting tokens if you're handing out tokens? Do you have an API server? Is it protected? Where's your DNS? Is DNS protected? That's the way I would wipe out a stream. I would take out DNS, remove the address. So there's all kinds of things that people don't realize that go into these live events. The ad insertion model, like how is it being monetized? Is it a paywall? Are you having people put in an email address? Once they do, what are you doing after that? Are you authenticating every user?
Can you process a lot of credit cards in a very short span of time? What's your fraud scoring?
Yeah, I mean, there's a lot of things involved, and the most important thing for a live event is you got to have some kind of observability, right? You got to have monitoring involved because you don't want the hair on fire conversation and say, "Oh my God, I got 5 complaints on Twitter. That means everything's broken." Well, wait a minute. That means that everybody in Iowa is having a problem. Everybody else is fine, so it's okay. There's levels of uh, of issues that you have to be careful of, right?
Akamai doesn't play in the like the LVC distribution world, right? Like these are other companies that are going and getting the signal from broadcast trailers and doing satellite distribution or picking it up from downlink stations. I mean, so the customer's still going to have to go out and figure out like what their signal source is if they wanted to redistribute, or is it at this point can they come to Akamai directly and say, hey, we want to, we've got the content rights to serve this traffic that's going to be going on this day. We need end to end here.
So yes and no. So now that we have a cloud, we can talk to our either partner base or even customers or companies that do that. Like I'm talking point to point. I'm not talking about monetizing it for them or getting the source. Um, but like Zixi, for example, is deployed on Akamai's Linode platform as well as others, so cloud platforms. So getting content acquisition from a venue that has Zixi capability is fine over Akamai. And then you've got companies that want to have an encoder on site, like a Media XL, for example, on prem, and then send that over terrestrial means rather than satellite to Akamai, whether it be our cloud or whoever else. But it's usually our cloud that because we're involved, we're talking about it. So we're talking to MediaXL and saying, hey, we've got this, event going on. We'll call it Outside Lands or whatever in San Francisco. I don't know if that's still going on, but we'll have an encoder there, and we're going to push it to our LA server or San Francisco server, and then we'll do the encoding from there. So because we have this set of toys, you ask if we do this, and we didn't, but doesn't mean we can't, right? And it also doesn't mean that we're qualified to actually have those conversations. We actually have other partners that actually have those conversations probably better than we do.
The major telcos all got into the space of doing content distribution, and they came up with, because you've got fiber running into these facilities, and you're like, okay, well, here's another service we can offer, and that service is usually, we can take and what was it? We could take a feed, an SDI interface out of whatever it is and plug it into our network, and then endpoint that anywhere else on our network, right? But then the problem with that is, the telcos that had encoding options, you still have to convert it into a signal that something else can deal with it, and for a long time that was just, can you convert it into RTMP, and then somebody else can at least take and transcode RTMP into something else and then shove it out the other way, right? But you get rid of all that encoding platform and you say, oh, all we do is we just take SDI in and SDI out, and you got to figure out the next thing. It's like, wonderful. Now, what are we going to do with this thing now?
Yeah. So we've worked with our customer or our partner, Atem, for those types of workflows. So Atem and MediaXL, they both have point-to-point gateway solutions. So they'll deploy a server on site, whether that customer. Most of our customers that want something like this, they're already using somebody like Atem or MediaXL. So they're the ones that tell us, hey, we want to use MediaXL. So we're like, okay, great. Guess what? They've been qualified to run on the node. So all we have to do is deploy, their encoder. So once we get the signal, you send it SRT to your encoder, and then we'll get it over whatever. It'll be SRT probably from their point to our point in the node, and then we distribute it however they want to encode it from that point, right? That's the hero encoder solution.
With the exception of, major geographic calamities, train fire in a tunnel takes out all the fiber going into Philadelphia, right? Like bridge collapses with a whatever and takes all the fiber going between, Santa Cruz and San Francisco. There's still capacity problems and capacity planning. This game has changed because the amount of what's shifted from traditional distribution of satellite or cable or over the air broadcast now is moving on to network internet-based delivery, right? So that changes your capacity requirements. So there's like that mess of it. Assuming that that's all perfect, you see these big events take place that are live or simulated live that fall over, right? And what's the experience from the people when they see it fall over? They can't get onto the stream. They can't actually show. They end up with a low bit rate, pixelation. Outside of just like, some aliens landing and the entire world turning in at the same time to watch the same live feed, like what's actually going on there that, has caused that or can be, done differently to alleviate that, maybe is a better way of phrasing it.
So there's a whole bunch of reasons in the workflow, from first mile, middle mile, and last mile. The most common use case for what you're describing, and I think what we're both kind of alluding to, is unpredictable traffic that you didn't plan for. And then when that happens, you get, either signal loss or rebuffering or pixelation. Whether that's at the last mile, because neighborhoods are all watching, the same thing at the same time. I personally experienced that last Friday. I was watching, from my house, and I was like, "Oh, this is really pixelated." My buddy across the street said, "Are we allowed to mention what we're talking about?"
I mean, I don't think we'll get in trouble. I mean, look, live events are a different animal, right? World Cup, big events, major sporting. I mean, so it's usually major sporting events, right? And now, I mean, we don't know what the actual stream numbers are of the Tyson Paul fight, right? And I don't know if we'll ever see that disclosed. I've seen numbers everywhere between like 60 and 100 million people watching that, which is from a scale of that stream, like is bananas. Like absolutely bananas. Like, oh, like is it 100 million people watching that? Like, I'm sorry, nobody. You want to talk about capacity planning? Like,
Yeah, we usually lop off the last zero when a customer tells us that they're going to have that many, right? It's like, okay, yeah, sure. you know, but
I mean, even at 60 million, that number is absolutely bananas. Like, it's
but they have a captive audience, they have subscribers, right? So it's that scenario where the event is not also broadcast on TV like the Super Bowl, where people have a choice, right? You have cable providers that not everybody has cut the cord, but for Netflix, there is no cable channel for Netflix. So they definitely have 100% of their users streaming content, right? And then um, they didn't do pay per view.
I just looked it up. The reports for 2024 were 124 million people watching the Super Bowl. So the 2024 broadcast of the Super Bowl, and that's broadcast and streaming. It's everything.
So that's both.
Yeah, global distribution, broadcast and streaming.
Yeah. So when you're talking 65 to 120 million for Netflix, that's a huge amount. I mean, look at the demographics. You got people that are older that, saw Tyson bite the ear off, and you got younger generation that have been growing up watching the influencer, right? So, you got it was the perfect storm for a lot of users. Um, I think they got caught off guard. And whenever you build out, now Netflix has super smart people working there. This is not a dig on anybody. It could have been anything in the workflow. I have no idea what actually happened.
If you have, by the way, just as a little segue and pause here, if you haven't read any of the Netflix engineering blogs on how they've actually architected their edge compute appliance, their edge appliances, and you're interested in this stuff, like go to their engineering blog and read it. I mean, what they're doing is phenomenal. I mean, and also we were talking earlier about like these like simulated live or like hot cache events. A lot of intelligence they built into their infrastructure to understand like, okay, we're going to release this season is now going to drop on this date, and like let's warm the entire network. I mean, this really, it's incredible. It's incredible engineering, and it's very sophisticated.
Yeah, and from a VOD perspective, they definitely got it figured out, right? And they haven't been doing live that long, so maybe and again, I think they have very smart people. I think this is probably one thing that it's making the news everywhere because it happened, right? But there are certain things that you do in this type of scenario, old school stuff, like, oh my God, we're rebuffering. Let's lop off the top bit rate so that we can lower the actual, usage in terabits per second, right? That we're actually having to satisfy. And there could have been something called a waiting room. When you go to a site that already has more people than they expected, you're like, hey, hold on, we're full right now. Just watch this, watch this other material while we wait for a slot to open up, right? That kind of thing. We've been doing that for years, right? And then there's, the player logic, like you say, what do you do if you hit some issue on a CDN, multi CDN? Netflix doesn't do multi CDN. So, this is a scenario where overflow might have helped them, but, I'm sure they're going to learn from this and they're going to make sure it doesn't happen again. But those are the learning.
They've been doing live events, and they're going to have more and more live events. I mean, the question is do you have anything that generates this much traffic, and at what pace do you get back to this point? Like, because I mean, if you're only talking about like 10 to 20 million people, which is still like bananas numbers when you start talking about like a live stream being consumed, like that's a really big event. I mean, you used a minute ago, like we have too many terabits of traffic. We got to lop off a bit rate, right? I'm still when I got on the internet, I had a 1200 baud modem guy, right? Like, I mean, now of course we're out there architecting and deploying like 800 gig backhaul for people, but like it's still like conceptually, like, oh, we just brought up 800 gig backhaul between these two markets, like X, And like every single time at like 1200 baud modem like flashes through my brain, you know?
Yeah, I mean these numbers are crazy. Like we've I can't tell you any numbers, but we do the streaming for the Amazon, or yeah, Amazon football on Thursdays over the Akamai platform. So we get definitely they've you mentioned reserve capacity. We have customers that have to reserve capacity because if not, it's a shared platform. We're going to have other people that are impacted, so we have to make sure that we get that reserve capacity. Even on a CDN, there is no such thing as unlimited capacity.
Who knows what the meetings are going on right now inside of Netflix talking about this? And by the time, people, like, I mean, this will become long tail at some point. Like 2 years down the road, maybe there's a retrospective that comes out and somebody talks about it. And we get a lot of details out of it. But um, even in the cases of Amazon streaming, uh, football, I mean, they have a platform that they may or may not have something to do with, right? And they're still out there making sure they have capacity for it. I mean, at some point, like we talk about like risk and resiliency a lot, in operations, and and a lot of times, like I think this is the difference between trying to have like trying to eliminate single points of failure and any like spaghetti diagrams to like actually having like an appropriate level of resiliency and disaster recovery planning of like, well, what do you do?
Yeah, it's all about building the run book so you're not making hair on fire decisions, right? I mean, you got to basically predict the worst, and you're always going to miss something. So
I mean, but that's the other side of it, right? Like if your steady state is 20 million streams and all of a sudden you've got 100 million going on, right? Like how do you 5x your capacity and capacity planning? Like nobody's planning for that. Like the days of being like, oh, we're going to have triple our steady state, we're gonna we're only at 30%. Like nobody's running their network at 30%. Everybody's, it's just not cost efficient. You gotta be way up there.
Akamai is not the only CDN that has we call it the velvet rope, but it's basically a capacity restriction that all of our customers are under. When you sign up for a contract with us, we put the velvet rope on based on what your contract size is. If you hit that, we are going to prevent traffic on your behalf because you've hit it, right? And there's a little bit of a buffer that we allow people, but that's to protect all other customers, right? We can't have one customer be the noisy neighbor on a CDN. It just doesn't happen. So in Netflix case, they don't have the ability to do that. They're their own customer. They're their own CDN. They're not failing over to anything else. So it's
So what do you think is going on right now? I mean, like if I mean we can like segue and not use like Netflix as a thing here, but like, you know, Monday morning you come into a meeting and this has happened, right? Like what's going on at that conference table, and what's the you turn around and the first thing is like, okay, uh late night cable television is talking about us, social media is talking about, like, this is like the worst case scenario in terms of, I mean, it's good and bad, right? It's good because you're relevant in the zeitgeist. Yeah, your stock's up, you're relevant in the zeitgeist, you had a huge event, but then like people are like, oh, it didn't work for me, did it work for you? Like everybody's has a story of somebody being like, oh, it worked, it didn't work, like everybody's talking about this thing. And like the first part of that becomes, if that capacity, that stream demand was 5 times what your normal delivery is there even a conversation around capacity increasing on your network, or do you just immediately just say like, what do we do from here?
yeah. So first, they're probably having a root cause analysis conversation, right? Like, what is the cause of this? Was it some stupid configuration that we botched, or was it really legitimately more traffic than we expected? Which everybody thinks that that's what it is. So let's go with that for now. Um, then you then you come up with the real hard numbers of how often is this going to happen? Is this going to be our trajectory? You know, with Akamai, we set records every year, and then it becomes the norm for the next year. It's constantly going up. So do you have the build out capacity conversation now, or do you do a hybrid of both? Do you build some out but also have some plan to say, well, what do we do if we get into this situation again? Do we have a failover to another CDN? Do we go and lop off the top bit rate? Or do we have a velvet rope, or not a velvet rope, but a waiting room scenario, right? There are ways to prevent that high capacity event, but is it worth it to the business? Do they want those eyeballs to see that fight? Absolutely. Do they want those eyeballs to see it at 300 kilobits per second? Absolutely not, right? That's not good.
They saw it, but they're not happy.
Right, right. So, there's ways that they could have prevented this by maybe having some time splicing, right? So right now they did it in Texas, and where they had, everybody on the East Coast. I'm on the East Coast. I had to stay up till 11:30 to see the main fight. That's past my bedtime. So, but I did it.
It's hard to keep me up until 11:30 at night nowadays. Like it's just
But everybody on the West Coast, it was 8:30, whatever, and the pre-fight, around 6, whatever. But that's what you're playing with, right? And then what about the people around the world? I mean, they watched it. They got up in the middle of the night and watched it. I don't know. I don't know what the numbers are, where their audience was from, but
but this, I mean, that's a big problem, right? Because like Olympics, like U.S. distribution of Olympics, I hate it because like, oh, by the time you even wake up or even they think about broadcasting anything to show you what's going on with the Olympics, it's like I've already all the clips are already on social media. Like,
you've got 5 gold medals. Wow. Let me go back and look at where we got those.
and the media shifted. I mean, it's been shifting for years, but now the value in media is really being expressed in live events because it, like, you have to sit there, you have to watch it, you have to consume it, you have to receive the advertisement or the pay gate that you've put into it in order to get it. And like there is this, we're back to this thing where like it's happening right now, and it has a draw, right? So you're not going to time shift a live event like that causes different. I mean, this was the thing that's crazy is like over the air distribution is massively efficient, right? You have one tower, and like everybody that's within 20 miles of that tower can, or 50 miles of that tower, however tall it is, can get that signal, right? Like it doesn't matter if it's 1 or 50 million, like.
You bring up a good point. So, as you know, all streaming technology today is unicast. Not all, but most of it is unicast.
I rolled my eyes again. I'm sorry. I couldn't help it.
I know. So are we going to go back to the multicast? We need to, right? We need to have a multicast like network, whether that's true multicast or some hybrid where you have a signal coming in, like we talked about SRT. And then what do? Do you distribute that over SRT to different geographies and do the encoding there so that you have ABR, multi-bit rates there? So you're not distributing like 5 megabits per, or sorry, 15, 20 megabits per second across the internet for all these users, or are you doing less? I don't know. Is that the answer? Who knows?
I mean, multicast has been a thought exercise on CCIE exams since like the dawn of time at this point. And like how many it's this technology that like, oh, it's great on the surface, but it's never ever been deployed, like in a like.
But the reason it hasn't is because you have routers that aren't unicast or multicast compliant in the middle, right? It's the internet. But if you have a network like Netflix that has their own network, maybe you can probably build your own multicast network and make it work. I don't know. Or CDNs may collaborate and get together. I don't know. There's a way to do it, but we haven't gotten there.
Well, I'm thinking about like modern architecture here, and you still have the access layer, right? So what is the actual access layer? And the access layer is going to be a telco. It's going to be a cable company, an MSO, something. It's and CDNs and content providers ultimately are trying to get access to that access network. Okay, we're getting a little redundant here, but you go to a carrier neutral facility, you try to peer. You're a large distributor of content, so you get settlement free interconnection, you get nodes directly on their network, like whatever those different things are. But you're still at the mercy of that access network delivering on what your technique is from whatever that edge point is across that access network down to, and this is, I mean, this was the point of like peer to peer. What peer to peer is trying to solve, or one of the points that peer to peer tries to solve, right? I think the real solve with most peer to peer for streaming is more about can you improve the quality of video delivered to a location that has, limited bandwidth, or that middle mile is such an issue. But then you introduce and inject delay into that signal and distribution, and that's a problem as well with live events, right? Like, maybe if they're only delivered over the internet, it's not a problem. Netflix, we solved your problem. Since you have no television broadcast, you need to release peer-to-peer across your network, and it will solve this problem.
Or I don't know what I think their segment size is like 5 seconds, but maybe they could get away with larger segment sizes. But I don't think they had any problems with 5 seconds. I don't think that was their problem. But the latency conversation, even with the Netflix fight, you know, were they trying to keep low latency, and why? Because the only people that would have noticed are the people that were in the venue, right? I mean, it's one of those things where
Okay, so if you were doing a live event but did not have traditional broadcast at the same time, so it's internet only distribution, you're competing with social media in terms of that delay, right? That's what you're talking about, because the people at the event don't know what's going on. So really, you're just talking about the people at the event that are on the internet with social media distributing whatever's going on is your competition. From an architecture and delivery standpoint, delaying that feed 5 seconds, 10 seconds, 15 seconds, what does that do for you from a CDN and distribution and quality standpoint?
good question. So there is a point of no return that doesn't get you much back, but if you have low latency, when I say low latency, people doing it with like 2 second segments, the number of requests back to the CDN from the player is, compared to a 10-second segment, is 5x. So you have 5 times the request from every single user coming back and looking for new segments. Because basically, the traditional buffer in a player will buffer 3 segments, and then live segments will come in as they generate, and then you'll go back and get more. You'll go back and get more. So if you extend the life or the length of those segments, you have fewer requests per second. We're not talking about bandwidth. We're talking about actual requests. And those requests start to add up, going all the way back through the chain to the encoder, or to the layer that's after the encoder. And that stresses the entire workflow for all these users, right? You got all these requests going back and forth. So small segments is bad for very, very large events. So longer segments, if you can get away with them, better.
Longer segments would introduce, I mean, with buffering though, you're going to increase the total bandwidth requirement. So, like, are you on a teeter totter here where?
Yeah, a little bit. That's why I said there's a point of there's a point where that benefit doesn't really make sense. So that's why I kind of stopped at 5 seconds. They might be okay. I mean, you go up to 7 to 10 seconds. Any more than that, it's not going to work, because you get very large files at the higher bit rates. But then you do, chunked transfer. So there's all kinds of techniques in there. But there was another angle I was trying to think of, and I've lost my train of thought now. Darn it. Oh, so when I was watching this event, I noticed that when I got buffering and stuff, it would buffer, but it would still play. But the DVR window was the entire length of the event. So what I noticed is when I went across the street to my buddy's house after I stopped watching it here, I went over there and I was like, "What are you doing? I've already seen this." He was buffered a lot further back than me, but he wasn't getting any pixelation. So he was actually watching at least segments that had already been cached. So he wasn't getting any buffering or no pixelation. And I said, "Do me a favor, fast forward to the live edge." And as he did, then we got rebuffering. So to me, that means that yes, they were at capacity and they were saturating the actual requests that were coming in to the servers, at least that we were hitting. And I'm in Northern Virginia, so
Yeah, they should have a few servers there.
yeah.
That's interesting, right? So then,
So you're effectively pre-caching a live feed with your DVR window.
right. So, could you force that and a player and have a config flag and just basically force all the players to go behind time a little bit?
You want some users actually to be at the live edge to fill the buffer, and then you have subsequent users maybe start 15 seconds in. They'd never know the difference. Right? I mean, most people in a live stream, you can have that buffer scrub, but you can make that go away. I mean, you don't have to have it, but that's all configurable.
And then you just, I mean, again, you're just talking about what you're dealing with in terms of how far behind can you go before social media becomes an issue.
Right. That's why I said 10 to 15 seconds is probably all you need.
And again, if it's not being broadcast live, because the big issue with latency on live is if your neighbor across the street is watching the same thing and they're cheering for goals being scored that you're behind. And by the way, that happens between like satellite and cable and broadcast television. I mean, the big secret here is if you have the option to get an antenna on your rooftop and you want to watch live sports, you get a much better. Everything's better. You get it's the encoding is better. You know,
go backwards. Yeah,
yeah, but you get better bandwidth, you get better signal quality, you get a better, and it's actually like the delivery of it's much better.
Yeah. So it's funny that the broadcast customers that I talk to when they say I want low latency, I'm like, well, do you really want low latency? Because you're already 8 to 10 seconds behind with your cable broadcast. They're like, yeah. What do you mean? I'm like, well, if I give you 3 seconds, and then you're going to have people complaining that we're ahead of your broadcast. So, yeah, 8 to 10 is fine.
This specific use case is so specific, right? Because now you're talking about somebody who is the content owner or content creator who then also has their own network for distribution that is trying to use their own network for distribution and not lever anything else that's available to them on the internet to give them capacity to like deal with these events, right? So like outside of the rematch in 2 years, like doing this as well.
The smart move for them would be to have a CDN relationship as a fallback. I mean, it's the lowest hanging fruit method that they could do, right? If by chance they have an event that hits this order of magnitude again, that outweighs or outpaces how fast they can build out, then they have a safety net. Maybe they never use it. That's fine.
And the level of nerdery that like the people that actually would care or say anything is like so
Level of people that would know. I mean,
no, there's so few of them that would be talking about it and nobody would care. I mean, that's the thing. Nobody would care. So, I mean, so good news for everybody else that wants to do live events, right? Like you don't have to deal with this. Just go out and have multiple providers and a plan to really, I mean, what I'm regurgitating is like the first thing is do you have a way of actually knowing what is real and what is not, right? So observability, not like so and so's cousin's nephew's niece is like telling you that they can't watch it in the cabins in the mountains somewhere in Peru, but real observability, and then the ability to make a decision based on that traffic and a plan and some sort of resiliency, right?
yeah, I would say for most of the live events that we do with the larger broadcasters, like Super Bowl, for example, there's 4 months of planning involved because for Super Bowl, it's usually a different network every year. So the last time they did it, everything's changed. They're like, yeah, we're just going to use the same encoders and the same profiles. Let's talk to you about that. So, there's a lot of planning, and there's also different technologies that have come out. Even in the last, like we have seasonal things that, well, seasonal, yes, every year, but mostly, everything happens in every 2 years, like Olympics and things like that. That enough things change that, like for example, we're talking to IBM about the Masters. The Masters isn't until next spring, but we're already talking to them about, hey, what are you doing? How are you doing it? What's changing? Things like that.
And they have a great digital experience. I mean, you talk about like an annual event that just really does a good job. And compared to, I mean, I used to watch MotoGP and like horrible experience, like it's just I haven't watched MotoGP in a while, so I should probably go back and see what they're up to lately. But
Yeah, I mean, all of the technology changes so often that you have to have some kind of plan in place. And the run book doesn't change that often. It's what do we do if we have more capacity? Have you checked all the different points that touch the user experience? Every API, every ad call, the player, the landing page, the DNS, the streaming technology, all of that needs to be scrutinized, right? Basically looked at with a fine tooth comb or microscope or whatever you want to call it. And then when you have all that mapped out, then you're like, okay, where did we come close last year or last event? Where are the places that we're most concerned about? And then what can we do to either mitigate that in real time or mitigate that now, right? So what are we going to do when that happens? And then most important, who's going to make the decision? Because when when everybody's like, "Oh my god, we're falling over," and then somebody goes, "Reboot the server," and they were like, "Wait, who's authorizing that?" It's like, wait a minute.
Boy, there's stories there for me too. And the other good news, right, is by the time you figure out 720, then you have to deal with 4K, and you figure out 4K and then 8K, and then by the time you have 8K, then everybody wants to go from 422 to 444, and then you figure that out, and then the next thing comes out, right? So and the jump of each one of these things isn't like it's a logarithmic jump in terms of capacity and bandwidth requirements, right? And I'm upgrading my house right now to 2.5 gig to every station, right? And I mean, the joke about it is the only thing that actually needs it is my Xbox, but doesn't support it yet, So like, and the only reason that needs it is because when I sit down to play a game, it's been so long that I have to download some stupid update, right?
Yeah, and it's funny. I used to talk to news agencies that wanted the secret sauce for their mojos. And if you don't know what a mojo is, mobile journalist, right? They're like, how do we get them to upload content directly from where they are? I'm like, well, today, if I had that conversation, I'd say Elon Musk is selling a satellite dish for $150. That's what I would do. $150 a month.
I mean, going back in time, productions filming on the islands in Hawaii, right? Where you were renting satellite transponder time and you had a window, like you had this from this time to this time, and that was it. And I mean, you want to talk about like, do not mess that up, because like if you miss that hour, like you don't get another, you've got to wait till the next day.
Yeah, I'm sure you have. Well, there are horror stories that I've heard of, not that I've been a part of, but like, did we talk about the time zone for that time that we need? Like, really?
That's not the problem. The problem is not the time zone. The problem is daylight savings time zone shifts. And by the way, it's not uniform because different locations and countries change time zones on different days of the month. And then some also have decided that they don't go a full hour, they maybe only go 30 minutes. And so if you've ever dealt with time, you learn to hate it very fast, because it's like,
Even in our own U.S., it's. I was camped out at Lake Powell, and I was like, "Hey, let's go to Antelope Canyon," and it was right around the time of daylight savings. And like, "Oh, but on Navajo land, it's not. They don't observe, but they are within Arizona." And then, like, what the heck? I left the RV, and I arrived before I left. Like, this is nuts.
when I was in 5th grade, my teacher was on a cruise and crossed the international date line and skipped her birthday the entire day. She skipped the entire day.
That's awesome. That's worse than leap year.
I mean, you get into these like weird things where it's just like, I mean, this is great. The build out will be fun to continue to watch, right? Because and also, I mean, bless containers. Like, really, everybody wants to talk about, serverless and functions and this and that and the next thing, but bless containers and how and actually making workloads portable and like in a meaningful way that you can actually take and move this stuff around, because that's like the Nobel Prize of tech in the last few years for most infrastructure planning.
Yeah, we've got a. I'm going to draw a blank on the company name, Starts with an A. One of our qualified, compute partners, Avisha, that specializes in container migration because they've basically normalized all the Kubernetes infrastructure across all the clouds. So if you want to run a cluster that crosses multiple clouds, no problem. And then migrate from one to another, no problem. So, I mean, making a containerized workflow, we've got one encoding partner. I think I already mentioned them, that runs everything in a container. So they've got a two, what's their algorithm? If you send them a job that is 2 plus 1 divided by 3 or whatever it is, it'll spin up that many servers to actually process those jobs. So each server is capable of encoding two, has 2 slots for it, and then it'll automatically ratchet up and then automatically ratchet down. I mean, it's just so easy. It's done.
And then you get back into the financials, right? Where you like get to decide, do I want to put this stuff on bare metal somewhere and pay for it and just have 5,000 cores just sitting because I'm going to use it all the time, or use it enough that it makes sense, or do you just go rent it? And I mean, I go back to that in terms of like optionality. You should be making decisions because you've decided to make a decision, not because you got forced into something, right? Like that's a very different it's a very different way of dealing with the world.
Yeah. Do I send all my content to encoder.com and just get it back all done and I'm done? Well, whatever, but encoder.com.
So we got the Super Bowl coming up. We got a little lull before the Olympics. We've got World Cup coming up. I mean, those should be World Cup. I'm excited for it. In the North America. You want to talk about like nightmares for like people dealing with this stuff? You're going to have to set up broadcasts at 8, 10 locations, you know, and like, oh, by the way, like Mexico City, right? Like,
Well, and we got people that are in Latin America that are actually very successful in selling out our Brazil deployment location. It's like, that's where they want their content. Now, the dirty little secret is, a lot of the users, even in Latin America, are getting their content from Miami because the connectivity is better. But that's going to change, right?
it's getting better. I mean, 15, 20 years ago, I mean, the peering inside of Brazil, like, you know, one network wasn't talking to another network and they were all peering in Miami and it was crazy. And so we learned as operators really quickly just to put everything up in Miami because it was better. But it's nice to see Latin America building out in the same way as seeing like Africa, like meaningful builds going on.
Yeah, and it might not make sense to put the encoding workflow everywhere in all these edge locations, but all the API call, all the little things that you really need, um, the distributed architecture for, like the token authentication. Maybe that should be closest to the end user and distributed. That's the common access token thing, with the Harbor DB thing. So we've got servers in Argentina, we've got servers in Colombia. I mean, there's those types of things are important. You talk to Claro and America Mobile, and they have their own CDNs. That want to interact with a little overflow with Akamai. I mean, we've got really good solutions for them with this Linode thing. So I'm excited to see how that all plays out too.
Mark, thank you very much. This has been fantastic.
Yeah, thank you. Thanks for having me.
Really appreciate the time. And I mean, hopefully there's a rematch, like I'd like, I mean, there was plenty of hype for it. So
Yeah, I don't know. I mean, the more and more I watched that fight, I was thinking, okay, which fighter would have benefited at all if there was any KO, right? Like, if Jake Paul would have knocked out a 58-year-old, he would have gotten ridiculed by, oh, you just knocked out an old man. And
and if he had been knocked out,
yeah, and if he'd have been knocked out, his career would have been over. So,
I mean, but this goes back to like, Floyd Mayweather's like deals. And I mean, like, this isn't real. This stuff is just entertainment. They've just, I mean, like, The economics are different from a Netflix deal versus a pay-per-view deal, right? In terms of dollars received. But
I'll tell you what fight I was impressed with is the pre-fight. Those girls were like toe to toe. I was like, holy crap, this is like Rocky, real Rocky.
well, that was, I mean, that's the difference between the exhibition and the real thing, right?
I mean, I would have gone down after two of those punches, and they were like poof, poof, poof. Oh my god, it was amazing.
Again, exhibition versus real, right? Now you're talking about just a different thing. I mean,
Well, I think Tyson brought the crowd for sure.
oh yeah. I mean, they both. I mean, it was. I mean, this was definitely the spectacle of the year. So congratulations to everybody involved, including everybody that's locked in a room right now trying to figure out what to do next.
Yeah, I mean, it's sometimes a failure is a success, but I don't know about that. That might be a little too far to reach for this one.
All right, man. Thank you again.
All right, thanks a lot. I appreciate it. See you, Max.